make sure everybody understands the difference between a rational and an irrational number. And it's got nothing to do with the number's state of mind. It's got nothing to do with the state of mind it might put you into, I'm afraid. A rational number. Rational has to do with the word ratio, which is basically a fraction. A rational number is anything that can be written as a fraction as long as there's no radicals or decimals in the fraction. So the rational numbers are the set of numbers a over b, a divided by b, such that a and b are integers. They don't have a fraction part themselves. Now, a rational number may appear as a fraction, but it also may be a terminating decimal, one that finishes up, it's done. It does not go on and on and on, and it has not been rounded off. Your calculator doesn't have a way to show that something goes on and on and on, and it doesn't indicate when it's rounded it off because it got out to 8 or 9 digits, whatever your calculator shows. So you can't necessarily look at something on your calculator and determine whether that is a terminating decimal or whether it's been rounded off. It also may be shown as a repeating decimal. And again, your calculator is just going to round it off when it gets out to so many decimal places. So if it's a terminating decimal, we might have something like 2.37564, and it's done. Don't ask me what fraction that is, I don't know. Or a repeating decimal might be something like 2.375 with a bar over the 75. Now that would mean it's 2.375757575, where the 75 repeats forever. Notice that this number, if we compare it to that first number I put, 2.3756648, they're the same. Here's where they start to differ. So the top number is larger than the bottom number because the first digit beyond where they are identical, the 7 is going to be larger than the 6. So we can say that 2.375 repeating is greater than 2.375648. We know which one's larger. Irrational numbers are numbers that cannot be written as a fraction. It's simply the set of numbers that are not rational numbers. And there's no way to list them. There's no way to put them in order. I mean, you can tell which one's bigger, but it's simply the set of numbers that are not rational numbers. Examples would be pi, or the vast majority of your radicals. The square root of 2 is irrational. The square root of 3 is irrational. Square root of 4, well, that's equal to 2, so that is a rational number. But we've got the square root of 5, square root of 6, and so on. And then we've got cube root of 2, and the cube root of 3, and even the cube root of 4. We have to get all the way up to the cube root of 8, which would be 2. the cube root of 8 is because 2 times 2 times 2 is equal to 8. So that's the cube root of 2 cubed. So that's equal to 2. So you have to go all the way up past 4 to 5, 6, 7, 8 before you hit on a cube root that is actually a rational number. And then you've got 4th, 5th, 6th, and so on forever. Now, an irrational number could be given as a decimal that has a pattern where you can recognize what the next several digits are going to be, but it's still not actually repeating. So if we have something like 0.12, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, ... You can tell me what the next 6 digits are going to be, right? 1, 2, 3, 4, 5, 6. We can see a pattern here. We've got these, and then these, and then these. But at no point do you ever get into a pattern where it's repeating exactly the same digits. Having a pattern and repeating specific digits are not necessarily the same thing. If you need to put numbers in order to figure out which one is bigger, you want to list them all as decimals. It's much easier to turn radicals into decimals and fractions into decimals than turn them back into, say, fractions or something. So you want to list them as decimals and then compare them digit by digit. As soon as you get to a digit that's different, then you can tell which one's larger, and those are eyes. What else are we going to need to know? It helps if you know how to do a square root of 2 out on your calculator. Now, I'm just going to show you on one calculator. This is a typical scientific calculator, not a graphing calculator. Now, with a graphing calculator, a lot of stuff is going to be hidden in menus, although I think it'll probably have a square root sign. In some calculators, you have to enter the number, then the square root. And in the simpler ones like this, you would do that. So if I wanted to know what the square root of 7 is, first I have to turn it on, of course. Let's clear it. So I hit the 7. And then I would hit the square root key, which this actually has a square root of x. And so this is showing that the square root of 7 is about 2.645751311. It just got to the point where it had to round things off. Let's say the next digits were 0, 7, and it couldn't go any farther, then it would round the 0 up to a 1. So this is rounded off. This is an irrational number. It doesn't ever start repeating. Just because there's 2 ones doesn't mean it's ones forever. So you need to make sure that you're using a calculator that you'll be able to use on your test, and that you know how to do a square root on that calculator. And then later on, we may be doing cube roots and 4th roots and 5th roots and raising things to the, not just the 2nd power, but the 3rd, 4th, 5th, 10th, 15th, 27th power. So you're going to need to make sure that you've got a calculator that you're going to be able to use on your tests. You cannot use a phone on your tests. You cannot use the calculator that's on the computer on your test. So you need to make sure that you've got a physical calculator. Something like this should cost around $10. So don't go run out and get a $100 calculator. You're not going to need it for this class. Let's say we need to simplify something like the square root of 31 plus 4 times the square root of 5. To run this through this kind of calculator, I would hit 3, 1, square root plus 4 times 5 square root. When I hit the square root on this calculator, notice it's just got a single line of digits. It doesn't have multi-lines and it doesn't show anything as I go. So when I hit the square root sign, it's going to give me the square root of whatever is in the window at the time. So if I do, let me clear it out. If I do 3, 1, square root, it'll give me the square root of 31. Then I need to do plus. It hasn't added anything. 4, now this will follow order of operations. So when I hit times, it's only going to multiply the 4. So it didn't do anything. I want to do 5 square root. So when I hit the 5, now it's not going to jump up to a 20 because it doesn't know whether I'm typing a 5 or a 53. When I hit the square root, it'll give me the square root of the number in the window. So here's square root of 5. And when I hit equals, I get the answer to the whole thing. And if you want to try this one on your calculator, I get 14.51203627. And of course, this is an irrational number, and this is an irrational number. So the odds are pretty good that the answer will be an irrational number. Not 100% guaranteed. So if I want to multiply 2 square roots, let's say I want to multiply the square root of 5 times the square root of 3. I'm going to hit 5 square root times 3 square root equals. So I've got 5 square root, there's the square root of 5, times, my times is an x, of course, 3 square root's going to give me the square root of the 3 equals, and if you want to try this out on your calculator to make sure you're hitting the right keys, 3.87298 3346 is as far as mine goes, and that appears to be an irrational number. Also, I want to point out the difference between something like 0.04321 with a line over the 21 and 0.4321 with a line over, say, the whole thing. Those aren't the same number. This one is 0.3212121, etc. This one, I'm going to write it under it so we can see which one's bigger. It's going to be 0.4321. Well, what's repeated here? The entire 4321, right? 4, 3, 2, 1. Now, when we look, we'll notice we got the same. Here's where they start to differ. And so this one is the larger one. So this is all you have to do to put numbers in order. One last thing I want to talk about is the difference between something like 0/3 and 3/0. Now that's not even a word, and there's a reason for that. It is possible to have 0/3. Let's say you have a candy bar and you break it in 3 pieces. So you have 3/3. You give one away, you're down to 2/3. You give another one away, you're down to 1/3. And you eat that, so now you have 0 of your thirds. 0/3 is equal to the number 0. 3/0, on the other hand. 3 zeros doesn't exist. This is undefined, and I'm going to show you why. But when you see the word undefined used in mathematics, instead of undefined being everything else in the world that isn't defined, undefined in math means a very, very, very specific thing. It means that somebody tried to divide by 0. A fraction is nothing but a division problem. A over B is equal to C if C times B is equal to A. In other words, 6/3 is equal to 2 because 2 times 3 is equal to 6. And I can say 0/3 is equal to 0, which works because 0 times 3 is equal to 0. This is this 0. This one is this 0. But what about 3 zeros? 3 zeros equals what? Well, all we have to do is find something that multiplied by 0 gives us 3. You see the problem here. Anything times 0 is going to be 0, right? There is nothing that exists times 0 that's going to be 3. That's why this is undefined, because it's meaningless. It doesn't exist. I'll show you another cute one. What if we had 0/0? Well, that equals 0, right? Since 0 times 0 is equal to 0. But wait a minute. Anytime you have a fraction where the top and the bottom are the same, that's equal to 1, right? So 0/0 ought to equal 1. Oh, well, it does, because 1 times 0 equals 0. So this equals 0, and it equals 1. And it equals 5. Sure it does. 5 times 0 is equal to 0. So this equals anything, and this doesn't equal anything at all. And this is actually not even called undefined. This one is called indeterminate, because we're pretty sure it equals something, but we're not able to determine what that is. Even in calculus, they don't deal with this one real well. Okay, so this is how you deal with rational and irrational numbers. So I hope you found this interesting, and I hope you have a little better understanding of what would be a rational number, what versus what's an irrational number. Remember, if it's written as a fraction with no decimals and no radicals involved, it's automatically a rational number. If you can divide it out on your calculator, it's automatically a rational number. If you have to use a root key to get it, then unless it happens to be one of the ones that gives you a terminating decimal, it's an irrational number. We'll see you later. Take care. Hope you enjoyed this. Bye.